Okay, so for today, 4.8 is complex numbers. The biggest thing for complex numbers is they're going to use the I variable. And when you see the I variable, it's always going to be italicized. And that way it kind of stands out different from other variables. When you use the I variable, the big thing for the I variable is that it's basically got one kind of a math equation that goes for this thing. The big thing that you've got to have for this part is that I squared is going to equal negative 1. And we're going to use that I squared and negative 1 on not everything in section 8, but a lot of things in section 8, we're going to use those two things to kind of go back from it. Now, here's the first thing they're going to do. If you go back to what we were doing yesterday and even the day before that, that up until now, if we had to do the square root of negative 25, yesterday we were doing the quadratic formula, we were plugging in the numbers and working through it. And if you remember, if we did square root of a negative number, just so you can kind of see it here, if we did the square root of a negative 25, it came out to be a domain error, which means that basically that answer was no solution. Okay, so that's everything from 4.7 all the way back to chapter 1. If we had square root of a negative number, it was no solution. Today, though, here's where we're going to change this. So everything in 4.7, now we're going to replace the negative that's in the square root with an I squared variable. Now you may be looking at going, but there's not a negative 1 in here. Okay, so here's why we kind of set this up and show you exactly what we're going to do. Okay, so let's take the negative 25 that we're going to take the square root of. That here's kind of on the side over here, here's what we're going to do. This is kind of what you have to think about. You don't have to do this. Once you get comfortable with it, you can kind of skip these two steps. But with the negative 25, the first thing you want to do is think about that as being negative 1 times 25. And that's where you can kind of get the negative 1. And the way we're going to set this up and solve it is we really want to put that negative 1 at the end of it. So just reverse those two numbers and make it 25 times negative 1. And now this is when we're going to go back to this part up here. Now we're going to take out this negative 1 and replace it with I squared. Question?
So every time it's a negative, it's going to be no solution?
Up until now it was. Now we're going to have a solution, but it's going to be a little different. We're going to show you how that's going to work. Okay. So take out this negative 1 and basically just replace that with I squared. Okay, and if you're doing the square root of two things, that now we've got the square root of 25 and the square root of I squared, you can almost separate those into two parts. You can do the square root of 25 and you can do the square root of I squared.
Is that C?
That is an I squared. Yes, it's always, and the I will always be italicized. It's always going to have that curve looking to it. You won't see the I, unless they don't have the italics print, you won't see the I like that. It'll always have the curve to it. So it's like that. You just wanted to be on YouTube, didn't you?
I already know. I'm already on YouTube. I made it on my blog.
Okay. Okay, now you can take the square root of 25, which is 5. And if you square root something squared, the square root and the square root cancel each other out. And that'll leave you with just I. So that's going to be the answer we're looking for right now. Okay, so the only difference is, if we had taken the square root of 25, it would have just been 5. If you take the square root of a negative 25, you're just going to put I in the answer to let you know that, okay, if we had actually done this on a calculator, it's going to tell you that this is no solution. But if they tell you that we're going to be able to write it in complex or imaginary form, you just put the I in there to let you know that, okay, this was a negative number when we started, so it's not really a 5, it's a 5 with an imaginary number attached to it. So it's like if it's not a real number, it's like you don't have a real friend, you've got an imaginary friend. Same thing. If this is not a real solution, it's an imaginary solution. Kind of, if you want to look at it kind of that way. 7 and 11.
The little one is so cute, but she's kind of shy and she doesn't like each other.
Okay, so let's do one more of these, and this will kind of, again, work on simplifying it where it's not a perfect square root at the end, and kind of a little bit of practice here. Okay, so very first thing. Now, again, you can kind of take the shortcut. The red part up here, this is what you've got to think. If you want to kind of just skip it and go, all right, this is going to be the square root of 12I squared. But again, if you kind of go through all the steps, it's negative 1 times 12. And then you kind of reverse the two numbers to make it 12 times negative 1. And then you're going to take the negative 1 out and replace it with I squared. So it's one of those things, if you're showing the work on the test, you don't have to show me these two steps. You can just go straight from here to here if you want to do that. Okay, so now you got to take the 12. And again, think about it separated as two parts. That's the square root of 12 times the square root of I squared. And square root of 12, that's not a perfect square root number, so here's where you've got to take the 12 and break it down. You can do it a couple of different ways. You can do 2 times 6 or 3 times 4. If we start with 2 times 6, then you make it 2 times 3. Okay, so with the 12, we've got 2 times 2 times 3. There's your pair of 2's. They got an exit buddy, so the 2's get out. 3 stays on the inside. And when you square root I squared, well, that's just going to become I. And there you go. There's your answer. Now, depending on the homework, and I'm okay with that answer. Sometimes in the online homework, they want the I not at the end. Sometimes they want that I behind the 2. And that's one of those things where if you get a wrong answer in the homework, if they don't like this answer, you may want to click the view example to see, because sometimes they want the I variable not on the end, they want it here. I'm okay either way. As long as the I is not underneath the square root with the 3, whether it's in front or behind it, I don't care. As long as it's not in the square root, it'll be okay either way. With the italicized I's, they will kind of look that way. Yeah. Yeah, they do look similar to C's. So. Okay, so there's the first thing that you'll do. They'll give you some numbers and have you simplify. And again, the only difference in the answers, if this was a square root of 12, the answer would have been 2 squared of 3. When they put the negative in, that just means you're going to have the I in the answer every single time. And that's the one connection they want you to make. If you have a negative in the square root, you have to have an I in the answer. And again, it's not a real number, it's an imaginary number. Okay, so there's where you're simplifying the parts of it. The next thing they're going to do is they're going to look at what they call complex form. And it's just getting the numbers written a certain way so it has a pattern to it every single time. And complex form is going to be what they're going to call A plus BI form. And basically is this. It's almost in two parts. The A part, that's going to be the real number part. That's going to be a 2, that's going to be a negative 5, that's going to be a 6 or a 7 or a 12 or something like that. The I part back here, that's going to be the imaginary part. And again, the I stands for the imaginary, so whatever has the I part of it, that's always going to be on the back side of it. The real number part is going to be in front. And for most of the time, it's not a big deal. Now, a couple of things we're going to do with it, that if you've got it in complex form, it's going to make the next things we'll do kind of there. So let's do a couple of just a quick examples to show you to make sure when we're going through these. So let's say you get an answer. We'll just make a quick T-chart. So let's say you get an answer that's negative 6I plus 3. Okay, now if on the test, if all that work we do with these, I'm going to ask you to put it in complex or A plus BI form. That if you get it to here and you leave it here, that's probably going to make you lose a point on one of the questions. Sometimes it's a half a point. If you do it once, it's not a big deal. If you do it twice, it's hard to go back and take a point. But technically, if you do this, they want the real number first, so this 3 would go first, and then the minus 6I would go second. So that's, if you put it in complex form, that's really what the answer is supposed to be. Okay, let's say an answer that was just 2. And again, this is, if the answer is just 2, that's okay, but they're kind of getting you ready for the next thing we're going to do, which if you've got an A plus BI form is really easy. That if it's an A plus BI form, if there's no I term here, just write that as a 0I. And kind of along the same lines, if you have 7I as the answer, you know, if you were to put it in true A plus BI form, it would be 0 plus 7I. Okay, now, test-wise, if you tell me the answer is just 2 and you want to put 2, that's fine. You don't have to necessarily write it this way. But what they're doing is they're kind of saying, all right, if you understand A plus BI form, making sure you put the real number part first and the I part of it second, the I term second, they're going to have you do a couple of things with this. And the first thing they're going to ask you to do is they're going to ask you to graph a complex number. Now the good news is it's not a hard graph. This is not going to be a quadratic or linear equation. This one's going to be just, here's a complex number. It's going to be just one ordered pair, just one point on this plane that we're doing. So when you have a complex number that's A plus BI, the real number part that's here, that's going to be the X value. The imaginary number, that's your Y value. And so that's when they talk about writing something in complex form. That's when if you get answers like this, you've got to have them written like this so that if you do have to graph these, you've got 2 numbers for your ordered pairs. And that's really the whole reason that they have you go back and do that. Okay, so here's what we'll do. We'll just graph like 4 or 5 of these. Make that a capital A. So we'll do 5 minus 2I. Let's do negative 3 plus I. We'll do 4I. And then for D, let's just do negative 1. Okay, so just drawing a quick XY axis. Again, it doesn't have to be super detailed. You can go 5 on the X axis, and then you can go 4 on the Y axis, up and down. That should be fine. Shouldn't anything below, I think 2 will be okay there. So what we'll do is, these are the numbers that they'll tell you in complex form, and they'll tell you just to graph these numbers. And what we'll do on the side over here is actually write out what the order pairs would be. Okay, so the first one, it's 5 minus 2. Well, that's your 2 numbers. It's 5, and it's negative 2. For the second one, we've got negative 3 plus I. And remember, you can basically put a 1 in front of that, so that's going to be the order pair at negative 3, 1. Okay, for 4I. Again, if you write it in what a true complex form, it would be 0 plus 4I. So I'd make it 0, 4. And then the last number is -1, and technically that's -1 plus 0i. So it would make it a -1, 0. So that's the biggest reason they go back and look at the complex form, is that, you know, the order is not necessarily important unless we start to graph it. Then if we graph it, we have to, you know, define which part's the x value and which part's the y value. So that's why we always go back and write it back in complex form. If you graph those numbers, we've got 5, -2. So 1, 2, 3, 4, 5, and down 2. There's your A. B is at -3, 1. It's over here. C is at 0, 4. 1, 2, 3, 4. Put you up here. And the last one at -1, 0. That would put you right there. So when it comes to graphing, the graphing is a lot easier than the graphing we did in the first part of chapter 4, because we're having to draw the vertex and find the intercepts and graph the quadratics. This one, it's just an ordered pair. They give you one complex number. That's just one ordered pair that you have to graph. You've got this one where we have 4 different complex numbers. You've got 4 ordered pairs you have to graph. Okay, now one more thing with just a basic setup here. After they've had you just get a number in complex form, a plus bi form, ask you to graph it, one more thing they're going to ask you to do is to find the absolute value of complex numbers. Okay, it starts off with the same thing. If they give you some complex number, and without getting specifics on it, if it's just in a plus bi form, then the next thing they're going to ask you to do is they're going to say, all right, if you've got some complex number that's a plus bi, and then they'll actually put that number in the absolute value symbols. So you've got a plus bi inside the absolute values. And to get that number, to find the absolute value, then you're going to do two things. You're going to find a squared and b squared, add those two things together, and then square root it. Okay, let's do a couple of, and two problems, and this will be good for two things. One, it's going to, we'll find the absolute value of it, but the second thing is also it'll be a good review to go back and look at some simplifying on the square root parts, simplifying the radicals and breaking those down. Okay, so here we go. First example, we'll do two. First example, we're going to find the absolute value of 5 minus 2i. And similar to the things we've done before, when we were working with the quadratic formula, when we were working to find the vertex, when you plug in the a and b values from this thing, I would say put those numbers in parentheses. That way it lets you know that you have to square a positive number or you have to square a negative number depending on what they do here. So for this one, that's going to be 5 squared plus -2 squared. Okay, and before you do anything on these, the first thing you have to do is you're going to have to square both of the numbers. So 5 squared is 25. -2 squared is 4. And once you've got both of those numbers squared, then you go back and add those two things together. Okay, now here's at the end, this is where you have to practice on the simplifying part. Once you get it down to just a number, you've got to see if you can simplify that number any way possible. With 29, you start trying to check the numbers that you can break it down with. It's an odd number, so if you check 3, it won't divide into it. 5 doesn't go into it, 7 doesn't go into it. You go back and check all the odd numbers. There's nothing you can do with 29 because it's prime. So for that particular problem, that would just be your answer at square root of 29. Now, let me give you one where you actually do have to do a little bit of work at the end of it to kind of break it down and get the numbers there. Now, and again, the big thing on this one is that before you can do anything, and some people say, well, why does the squared cancel these out? You can almost think about having a big set of parentheses inside that square root. That before you can get rid of these squared, you have to get it down so it's just one single number that's here. Because inside the square root, it's almost like it's its own set of parentheses, if you want to think about it that way. Okay, so for this one, next one let's do negative 4 plus 2i. So it's the square root of negative 4 squared plus 2 squared. Okay, with negative 4 squared, that's going to make it a positive 16. 2 squared would be just a positive 4. And again, before you do anything at all, you've got to put those two things together to make it square root of 20. And once you get one single number, that's the part that you want to break down. Okay, and with 20, we'll do that on the side over here. You can do that one 2 or 3 different ways. If you start with 2 times 10, and again, if you're not sure, always start with your 2's and your 3's and your 5's first. So if you can start with, if it's even, you can divide it by 2. Go ahead and divide it by 2 first. So you've got 2 times 10, well, there's a prime number. 10 would be 2 times 5, and both of those are prime numbers. So if you work with 20, it's 2 times 2 times 5. And if you stick with your exit buddies, there's a pair of 2's, so they get out. That 5 doesn't have an exit buddy, so it stays on the inside. So your final answer would be 2 squared of 5.
So when you put the I in,
For this part, when you're finding just the absolute value, you don't worry about the I. You just worry about the numbers that's in front. Okay, let me give you one more on this one, real quick. So let's say they ask you to find the absolute value of 5i. If you want to, you can, again, if you can kind of think about that one, that technically that would be 0 plus 5i. So if they ask you to graph it, you'd have to think about it that way. And you probably want to, and you can do it a couple of different ways, that if you want to go ahead and do the absolute value, well, that's 0 squared plus 5 squared. Zero squared is 0, 5 squared is 25. When you add those two things together, that's just 25. But what is the square root of 25? Just 5, right? So sometimes, depending on the numbers they give to you, the square root may be gone altogether, that there may not be a radical, that it may be just that it's just a whole number that's there. Somebody's kind of thinking this and just throwing out there. If somebody says, well, if there's just one number here that you have to find the absolute value of. Will it always be that number down here? Yes. Because when you square the 5 to get 25, 0 is never going to do anything to this number, so you're going to square root it and get it back to this number. So if that had been 7i, this answer would have just been 7. If this had been 8i, that answer would have just been 8. So though if it's just one number, it'll always be just that number to get the absolute value of it. Okay, and then the last two things. We're going to do addition and subtraction, and then the last thing we'll do would be multiplication. They're going to ask you to add or subtract complex numbers. And most everything we'll do today with Section 8, it's going to be easy. I mean, there's a lot of stuff we're doing with it, but most everything is pretty easy. The harder things that we'll do will be Monday when we come back and talk about the second half of, or the last little bit of Section 8. But it'll be kind of a good review because we'll get a chance to go back and talk about all these things that we do today and then add to those just a little bit on Monday when we get the last part of Section 8. But add and subtracting complex numbers, it's basically this. You're just going to combine like terms. And the I variable in this case doesn't really do anything. It's just that it's an I variable. So for this part, you treat I like it's any other variable. So for adding and subtracting complex numbers, this one, it's really no different than anything else you would have done in either geometry or back in Algebra 1, or if you took connections. It's the exact same thing here. The I variable doesn't really do anything. It's just, you can think about it just being like x. You're going to add it, subtract it, just like you would do with x or y or t or whatever variable they give to you. So this one, there's really nothing different about this part at all because you're never going to have I squared when you add and subtract, so you don't really do anything funny with I. You just combine them like terms. So it looks something like this. Let's say you've got 3 plus 2i. And they're going to ask you to add that to negative 7 plus 5i. So find your like terms. Well, that's going to be the 3 and the negative 7. You're going to do 3 plus negative 7. And then the I terms, you've got a positive 2i, and you're going to add that to another 5i. And from there, you just add or subtract. You've got 3 plus negative 7, which is the same thing as 3 minus 7. So it'll be negative 4. 2i plus 5i is 7i. And that's it. That's all you have to do. So when we tell you to treat I like any other variable, that means that when you add and subtract, it's really the exact same thing you've been doing, except instead of being an x variable like we always use, this time it's an I variable. Now, here's the one thing you've got to be careful of. So everybody kind of perk up and pay attention here. And it's not hard, but you just have to be careful with subtraction. So this is more of a warning that when you get to the subtraction part, it's not hard, but it's easy to get it confused and make a careless mistake and go through this one. So go ahead and kind of tell you up front on this one that this is where you just kind of have to be careful. Just make sure you don't get in too big a hurry, because I think that's the thing that happens sometimes. So let's say you've got 4 minus 5i. We're going to do minus 6 minus 9i. Now, if you're wondering why are these in parentheses, because basically they're going to say that you're going to back up here at the first part. It's one complex number plus another complex number. This one, it's one complex number. Now we're doing subtraction with another complex number. So they'll separate them off in the parentheses to start, just to know that it's two complex numbers that you're going to add or subtract. Okay, now here's where you have to be careful, because most everybody will see that this is 4 minus 5i. They'll do minus 6. Here's the spot where a lot of people make their mistakes. They'll change the sign of the 6. They won't change the sign of that second number. And what you have to do is you have to think about, basically for this part, is that this is going to be negative 1 times 6 minus 9i. So you're doing negative 1 times 6 to make that negative. You're doing negative times negative, so that's going to have to make that a positive. And that's the one little thing that sometimes people will forget to do. They'll change the first sign, they'll forget to change the second sign. And this is going to be one of those test questions that if you miss that second number, even if the first number is correct, I'm going to count this thing all wrong. Because the main thing I'm looking for really is that second number, that the I terms are going to be the right numbers with the right signs. So now you've got 4 minus 6. For the real numbers part, you've got negative 5 plus 9. I for the imaginary part. Okay, 4 minus 6 is negative 2. Negative 5i plus 9i, that would be a plus 4i. So test-wise, that's going to be one of those all or nothing questions. Either it's all right or it's all wrong. There's not going to be any partial credit when it comes to that one. Because most, and everybody that gets this, they'll get the first number correct. It's always that second number that it's 50-50 sometimes. And it's not because it's hard, it's just, it's one of those things you have to just be a little bit careful with it. Multiplying complex numbers. This one's going to be a little different. Now, it's still going to do the same thing. We're going to be doing the full method, and we're going to be doing distributive property. So that part's going to be the same, but here's the one thing that you're going to do. You have to replace I squared with negative 1. Other than that, you do I just like you would any other variable. Just like we're going to do the full method, and we're doing x plus 2 times x plus 3. So you replace I squared with negative 1. Every other time you treat I just like any other variable. Okay, so first thing we're going to do. Let's start you off with a distributive property first. So we'll say this part. Other than the I squared with negative 1, you don't worry about anything else. If you have just an I or just a number, you treat that just like anything else. The only thing you look for is if you have I squared. Now, you will not have I squared when you start with it. So that's one of those things, as you work through it, you'll get there. So for this one, if you do 6i times 2, just do a little distributive property. That's 12i. If you do 6i times 3i, that's going to be a negative 18. And when you do I times I, that's when you're going to get I squared. And if you haven't done some of the algebra stuff in a while, sometimes that's the one thing that kind of sneaks by people. Just remember that if you do x times x, that would be x squared. That if you do I times I, that would also be I squared. Okay, the only thing you do after this, the 12i is absolutely okay. The one thing you have to do, though, is that where you've got this I squared at the end, that's where you're now going to go back and replace the I squared with negative 1. So that makes it 12i. You do negative 18 times negative 1, that's going to be a positive 18. And that's an okay answer, but they're going to tell you to write the answer in complex form. So put the 18 first, and put the 12i at the end. So if you're doing distributed property, go ahead and do like a normal distributed property, multiply by whatever they give you. If you have I times I, that's the one thing you have to change, is that when you do I times I, that's going to make it I squared. And anytime you have an I squared, you have to take the I squared out to make it a negative 1. Okay, so after this, everything else we're going to do, we'll do 2 more examples. We'll do those with doing the full method. Because usually people need practice. It's not distributed property. Most everybody's usually good with that. It's doing the full method that people need a little bit of a review with. And with full method, basically it's a double distributed property. You're going to do 4 times 5. And you're going to do 4 times I. Then you're going to do negative 3i times 5, and then negative 3i times I. And the first time we do this, we'll kind of leave everything written out, and then we'll put it back together. So we've got 4 times 5, and then we have plus 4 times I. Negative 3i times 5, and then negative 3i times I. Okay, 4 times 5 is 20. 4 times I is just 4i. Negative 3i times 5 is a negative 15i. And negative 3 times basically a 1 there. If you think about that being a 1i back here. When you do I times I, that's going to make that I squared. That's the one thing that, if there's one part in here you have to be careful of, I think it's that one thing that when you do I times I, that's going to make it I squared. Okay, and the pattern should be the same almost on every single one of these. The first number usually is going to be fine. The middle 2 numbers, you should be able to add or subtract those 2 together. If you do 4 minus 15, that's a negative 11, and just put the I variable behind it. So that's where we're kind of combining like terms like we did on the other examples. And the one thing you do here is where you have the I squared, you have to take the I squared out and replace it with negative 1. So if you do negative 3 times negative 1, that's a positive 3. So final answer would be 20 plus 3, or 23, minus 11i. All right, and one last example that will, it's a practice of doing the full method here, but it's also a little bit of a preview of what we're going to do on Monday. So we're kind of hitting both areas here. It's still doing distributed property, still doing the full method here, but it's also a little sneak preview of what we're going to get to do on Monday. So let's say we're doing 2 minus 3i times 2 plus 3i. Okay, so first step, going through the full method here, we've got 2 times 2 for 4. We've got 2 times 3 for a positive 6i. We've got negative 3i times 2, that's a negative 6i. Negative 3 times 3 is a negative 9. And again, when we do I times I, that makes that I squared. Okay, and it should kind of follow through on the same patterns. Your middle 2 numbers, you should be able to add or subtract those 2 together. So you've got the 4 here. If you do 6 minus 6, that is 0, right? We've got the 0i. We've got the negative 9 times. Again, take out the I squared and replace it with negative 1. Now, the good thing about the 0i in the middle is, if you do 0 times I, that's just 0. And what's 4 plus 0? Just 4, right? Yeah. So the 0 in the middle basically just kind of knocks itself out. If you get a 0i, it just goes away. So that's 4. If you do negative 9 times a negative 1, that's a positive 9. And then 4 plus 9 would be 13. So depending on the numbers you get when they have you plug in, going through the distributive property or going through the full method, you might get numbers in the middle that the I term may just go away and be left with a whole number. It may also be that sometimes the whole numbers go away and you're left with just an I term. So it just depends on the numbers and how it works out when you go through the full method and how it'll kind of fit in together.